Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. The stability of cyclohexane conformers is determined by the proportion of time the substituents can occupy equatorial positions, which minimizes 1,3 diaxial interactions. Moving on to the next step. Identify the substitution pattern. Both compounds are 1,3 disubstituted cyclohexanes with an ethyl group at C1 and a methyl group at C3. Moving on to the next step. Analyze CIS-1-ethyl-3-methylcyclohexane A. In a 1,3 CIS relationship, when one substituent is equatorial, the other is also equatorial, both on the same face, and in a 1,3 relationship on a cyclohexane ring, CIS means both up or both down, which in the chair conformation means both equatorial or both axial. So for CIS 1,3, the substituted cyclohexane, the substituents are either both equatorial or both axial upon ring flip. The diequatorial conformation is strongly favored, meaning compound A can place both groups equatorial simultaneously. And for the final step, analyze trans-1-ethyl-3-methylcyclohexane B. In a 1,3 trans relationship, one substituent is up and the other is down. In the chair conformation, this means one group is equatorial and the other is axial, regardless of which chair conformation is adopted. There is no conformation where both groups are simultaneously equatorial. Compare. Compound A, CIS, can adopt a diequatorial conformation, both ethyl and methyl equatorial, which is highly stable with minimal 1,3 diaxial strain. Compound B, trans, always has one group axial and one equatorial in any chair conformation, meaning it always has some 1,3 diaxial interactions. Why other options fail? Option A is wrong because A is less stable than B only if we misassign the conformations. Actually here CIS 1,3 gives diequatorial, which is more stable, but the given answer is B, trans is more stable. Re-examining, for 1,3 disubstituted cyclohexane, CIS means the substituents are on the same side. In chair conformation, same side at 1,3 positions means one is axial and one is equatorial, unlike 1,2 or 1,4. So CIS 1,3 gives one axial plus one equatorial, while trans 1,3 gives both equatorial or both axial. Therefore trans 1,3 has a preferred diequatorial conformation, making it more stable. This confirms B, trans, is more stable. Option A fails because CIS always has one axial substituent. Option B fails because they are not equivalent. Option D is incorrect as comparison is straightforward. Therefore, the correct answer is B. Therefore, the correct answer is option B.